Hello everyone, I welcome you all in my class of CIS 3146 Embedded System. This is the first session of Embedded System class. That is why I have given week 1, and our focus will be on binary number system. What I have done, rather than creating a long video lecture of 1 hour, I have divided my lecture in several parts, and this is part number 1. I am Dr. Harimohan Pandey from the Department of Computer Science, and my email ID is given here, which you can use to discuss your doubt, or if you want to get any information in this module, then you can write me email. In the next slide, I have given the aim for week 1 session. So the aim of this week session is to understand number 1, number system and logical operations. So we want to understand what are the different number systems, their conversions. We will basically play with the number systems, and then I will explain logical operations in week number 1. So in order to achieve this aim, I have framed some objectives, and objectives are given in the next slide. So at the end of this session, you will be able to understand number 1, numbers and logics, various number systems. So we will discuss binary number system, we will discuss decimal number system, we will discuss hexadecimal number system, we will discuss octal number system, base 8. So these are the different number system we will discuss in week number 1. Then we will discuss the reason of understanding the number system, why we want to understand these number systems, what is the reason behind that. Then you will see number system conversion. So in this, you will convert a binary number system to hexadecimal or decimal number system or octal number system. Similarly, a hexadecimal number is given, you can convert it in other number system, that is binary, decimal or octal. If decimal number is given, then how you will convert decimal number in binary, how you will convert decimal number in hexadecimal or octal number system. So we will see the conversion of number system, and finally I will touch logical operations. So under this, you will get to know different logical operations like AND operation, OR operation, and NOT operation. So these are the different logical operations we will see in this objective. So all in all, you can see here 5 objectives are given, and we will achieve these objectives in different parts of the video lecture. So in this part, that is in part number 1, we'll focus on the first objective, that is numbers and logic. So here you can see why we want to understand the number system, because a number system basically plays a significant role in a digital system or digital devices. So that is why we want to understand number system, because all the digital device works on the number system, binary number system. So that is why we want to understand binary number system. So here I have given some questions like, in binary number system we will use only 2 digits, 1 or 0. So here 1 plus 1, in decimal number system it will be 2, 1 plus 1 will be 2, but here in binary number system it is 1 0. So why it is 1 0? Second example is, if this is 1 1 1 1, so this is not 11, but in decimal number system we call it 11 plus 11, it will be 22, but here it is 1 1 0. One more example I have given here. So here you can see 1 plus 1 1 1, and it is giving 1 0 0 0. So how we are getting these answers from these numbers? So we need to understand all these things in this session. That is, in part number 1, I will discuss all these things. Next, I will explain why number system is important, binary number system is important to understand. If you are working in computer architecture, or you want to understand embedded system in a better way, then you need to understand the importance of binary number system for digital device. So computer understands only binary number system. That is the reason we are interested in understanding binary number system. And we want to understand different operations. On binary number system. So that is the reason we want to understand binary number system. So here I have given some examples, like in computer, all arithmetic operation is done in binary. So arithmetic operation, it means plus, minus, multiplication, division, modulo division, all these all operation will be performed in binary number system. Then the comparison will be done in binary number system. Less than, greater than, equal to, not equal to, all these comparison will be performed in binary number system. Peripherals, that is input device or output device. Input device transfer the data, or output device accepts the data and produce the output in binary number system. That is the reason we want to understand binary number system. Next, all programs are stored in binary number system. So in memory, computer memory, the data will get stored in the form of binary number system. That is the reason we want to understand binary number system. Next, you will see all games are played in binary number system. So these are some important points which I have highlighted as a reason of understanding binary number system if you are using a computer system. The next slide is given for the reason of understanding binary number system. So here you can see it is important we can understand the binary number system. And why you want to understand binary number system? Because if we have the basic knowledge of binary number system, then we can manipulate the data, or we can manipulate the operations as per our requirement. Here I have given one example of a decimal number system. So you can see this number 358 is given in a decimal number system. So what does this, is it possible, that is, what does this number means, and is it possible to break this number into parts? So in the next slide I have given the answer of this question and this question. So here you can see I have taken the same number 358. So what does this 8 means? 8 is at one position, and there are 8 ones at this position. So what I will do, I will say then 5 is at 10th position, and this 3 is at 100th position. So 8 will be at position number 1. So I will say 8 multiplied by 1. Then this 5 is at position number 10. So 5 multiplied by 10. And then this 3 is at position number 100. So 3 multiplied by 100. Then you will get this number 358. So this is one position. This is 10th position. This is 100th position. If suppose one more number is given here, let's say 6, then it will be at 1000th position. So that is why we call it 6358. And this number is in decimal number system. So we call it 10 based number system. 10 based number system. The next slide will explain another number system, and it is called as octal number system. Here we'll use 8-based number system. So this slide will explain 8-bit number system. So here you can see a number is given 125. So this number will be at position number 1. So we will say 5 multiplied by 1. Second number is at position number 8. So we will say 2 multiplied by 8 plus 5 multiplied by 1. So this is at position number 1, and this is at position number 8, and this one will be at position number 64. So we'll say 1 multiplied by 64 plus, so we'll get 125, and this will be 8-based number. So this is octal number system, and here the base will be 8. The next slide will explain binary number system. So in binary number system, we use 2 digits. First digit is 0 and second digit is 1. So if you want to represent any number, any decimal number or octal number or hexadecimal number, then you can use only 2 digits, that is 0 or 1. And if you get 2 in decimal, then it will be 1 0, base 2, that is 1 plus 1 will be 1 0 in binary number system. Now here I have given one example for 3 bits binary number system. So this table will explain how you can use 3-bit binary number system to convert a binary number system in decimal number system. So the first position is 1's position, second position is 2's position, and third position will be 4 position. And it starts with number 0. These are the decimal number, and in this block I have shown the binary number. So if your decimal number is 0, so in 3-bit representation it will be 0 0 0. If the number is 1, so 1 position will be 1 0 0. If the number is 2, then position number 2 will be 1 and other position will be 0. If the number is 3, then 2 plus 1 3. So this position and this position, that is this one and this one, will be 1, and 4 position will be 0. For decimal number 4, this position will be 1 and other position will be 0. For 5, that is 4 plus 1 5, that is this position, and this position will be 1 and other will be 0. For 6, 4 plus 2 6, that is this position, 4 position, and 2 position will be 1 1 1 and other position will be 0. And for 7, 4 plus 2 6 plus 1 7, so all position will be 1. So that is why 1 1 1 1 1 1 is given. 1 1 1 is given in for 7. So here this is 1's position, this is 2's position, and this is 4th position. So this is 1 position, 2's position, and 4 position. So it will be 1 multiplied by 1 plus 0 multiplied by 2 plus 1 multiplied by 4, and it will give you a number 5. 1 plus 1 multiplied by 1 will be 1. This will be 0, and 4 multiplied by 1 will give you 4. So 4 plus 1 will give you 5. So 5 will be your decimal number. So here I have given how you will use a binary number system to convert in decimal number system. So 22, that is 16 plus 4 plus 2, it will give you 22. 24, 16 plus 8 will give you 24. For 31, all will be 1. For 10, 8 plus 2, that is 1 1, will give you 10, and 16, that is this digit, will give you 16. In the next part, we will see number